Okay guys, so today I'm only going to see you, twice this week? Today and on Thursday. Okay, so we have 2 lessons. The next time I see you after this week will be Monday, we review, and then we have a quiz before spring break. Okay, so that will be our quiz of polynomials. We'll come back, a couple lessons, then we have our unit test on polynomials. That's the biggest unit we have going this semester. Okay, so today is just going to continue, this whole unit continues to build. Okay. So what we did last time we were together, we talked about rational roots. Okay, what are the possible rational roots? Okay, so in this case, if I looked at something like this, a list, I could always get the possibilities. Now, before I start, there was a question, Timothy, you had one in the homework, right? Which one was that? Number 2? Okay, without listing all the possible rational roots, what is one solution? What do you think I'm wanting you to know there? There were 2 tricks. Yeah, if the coefficients add to 0, x equal 1 is a root. If the coefficients are positive, the root's negative. What is 12 minus 6? 6. 6 plus 2? 8. 8 minus 7? 1. 1 plus 1? 2. 2 minus 2? Coefficients all add to 0. So the coefficients add to 0. That means what? X minus 1 is a factor, and what is the root? X equal 1 is a root. Okay, without listing all the possibilities, I know that has to work. Okay, so let's make it work. You write down the coefficients. 12 minus 6, 2 minus 7, 1 minus 2. Those are my coefficients to x to the 5th, x to the 4th, x cubed, x squared, x, and constant. Bring the 12 down. What's 1 times 12? 12. 12 minus 6? 6. 1 times 6. Add that to 2 and you get 8. 1 times 8? 8 minus 7 is 1. 1 times 1 is 1. 1 times 2 is 2. Okay, so that means that this does work. Okay, so that means that x equal 1 is a solution. Okay, so this one we could have gone further to factor, but this was just saying, can you look at this and tell what one of the roots is without listing all the possibilities? Okay, so let's move into today's lesson, solving higher order polynomials. Okay, so we're going to continue to build on what we've been doing, but we're going to solve some higher order. That means like 4th degree, 5th degree. Everything you did before was pretty much 3rd degree. But here's our process. Step 1, use the rational roots theorem and the 2 shortcuts. If the coefficients add to 0, x minus 1 is a factor, x equal 1 is a root. If the coefficients are positive, the root is negative. Those are our shortcuts. Use rational roots to reduce as many steps as necessary to reduce the polynomial to a quadratic. If I start with a cubic, I have to find how many roots to get it down to a quadratic. 1. If I start with a 4th degree, I've got to find how many? 2. 5th degree, I've got to find 3. Okay, so that's our process. Find as many roots as I need to get it down to a quadratic, then solve the quadratic by factoring our quadratic formula. I think everything you did so far was factoring. There'll probably be some quadratic formula today. And then you write the complete factorization and be able to list all of the roots. Okay, so let's find all of the roots of this polynomial. First of all, what are all the possible roots? It's plus or minus the factors of what? Yeah, plus or minus the factors of 14 divided by the factors of what? 1, which is a pretty good number to have. It's not as ugly as the one that you guys started out with the homework. So this is plus or minus what? 1, 2, 7, and 14. Okay? Now let's check and see. Let's add these up. What's 1 plus 3? 4. 4 minus 5, negative 1. And I look at the rest of this. Am I going to get to 0? Will that add to 0? No, it's not going to add to 0. So the coefficients do not add to 0. So that means x equal 1 is not a solution. So do you think I'm going to start trying to see if x equal 1 is a solution? No. If you didn't see that, you could try 1 and it's not going to work. No harm done. So I know 1 doesn't work. I'm going to start with negative 1. So I'm going to try x equal negative 1. Okay, so if I bring the 1 down, 1 times negative 1 is negative 1. Add to get 2. Negative 1 times 2 is negative 2. Add to get negative 7. Negative 1 times negative 7 is 7. Add to get negative 14. Negative 1 times negative 14 is 14. Add to get 0. What does that mean? Negative 1 is a solution. So x equal negative 1. That is a solution. What is the factor? Yeah, x plus 1 is the factor. Okay, so I know that right off. Okay. Now what have I got to do? I've got to do this again. Okay, so I got to do it again with this polynomial. This is what? This is x to the what? Third plus 2x squared minus 7x minus 14. The rational roots are the factors of 14 over 1. It's the same list. Okay, I don't get a new list when I do this. Now, should I try negative 1 or not? Yes or no? First of all, should I try 1? No, I've already ruled 1 out. It doesn't work, okay? The coefficients do not add to 0. You can try it again here. These coefficients do not add to 0. So I'm starting over with my new problem being right here. That's where I'm starting over now to find another root. Again, should I try negative 1? I haven't ruled it out. Just because it worked doesn't mean it won't work again, okay? So if I'm trying to march down this list, negative 1 might work again, okay? You could have x minus 1 times x minus 1 being a polynomial. So let's try negative 1 again. So when I try it again, but I'm starting with this right here, 1, 2, negative 7, negative 14. Starting with the answer from the previous. So if I bring the 1 down, I get negative 1 and 1. Multiply here, I get negative 1, negative 8. Multiply here, I get 8. Don't even have to do the arithmetic to know that doesn't work, okay? So negative 1 is not a factor of, it doesn't occur twice, okay? It only worked once. So I've already used 1 and negative 1. Where am I going to go next? I'm going to try 2 and negative 2. So let's try 2. So let's just say we have 2. And let's copy down these numbers. 1, 2, negative 7, negative 14. 1 times 2 is 2. Add that to get 4. 2 times 4 is 8. Add that to get 1. 2 times 1 is 2. That doesn't work. Okay, what will I try next? Negative 2. Okay. So 1, 2, negative 7, negative 14. 1 times negative 2 is negative 2. Add that to get 0. Negative 2 times 0 is 0. Add that to get negative 7. Negative 2 times negative 7 is 14. Add that to get 0. What does that mean? What? What's my solution? X equal negative 2 is a solution. What is my factor? Yeah, x plus 2 is a factor, okay? Now I've found 2 solutions from original of 4th degree, so that means what I'm left with here is what? What is this? That's a quadratic, right? Okay. So this started out, this was x to the 5th, then this was x to the 5th, that was x to the 4th. If this was, excuse me, sorry. This was x to the 4th, I started out, that became a cubic, and then the cubic became a quadratic. So this right here, this means, this is what, x squared minus 7, that's what that means at the very end, okay?
So we do the first one and then we just do another one with the same root, like same negative 1.
Right here?
Yeah.
Well, if it works one time, it might work twice. Just because it worked doesn't mean I haven't ruled it out, okay? The only way I know it doesn't work is when I try it and it doesn't work, okay? Like you could have a polynomial that's x minus 1 times x minus 1 times x minus 1. If you were doing synthetic division, how many times would 1 work on this? It would work 3 times, okay? So in this one, if I multiplied it out, when you did synthetic division, x equal 1 would work 3 times in this polynomial. Okay, so just because it works, and you're doing subsequent, you have to try it again before you can rule it out, okay? So what is the factorization here? F of x is what? What's the first factor I found? X plus 1. What was the next factor I found? X plus 2. And then what was I left with? What? X squared minus 7. Okay? So that is my factorization. Now let's find all the roots or solutions. Okay? The roots are x equal what? Negative 1 and what? Negative 2. And then if I set x squared minus 7 equals 0, that means that x squared equals 7. X is equal to what? Plus or minus what? Square root of 7. Okay. 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 Now, try to figure out. I'd ask you for the factors here before I ask for the roots, but if I can look at all the roots, I can write this factorization. I can go one more step, okay? I can write f of x is x plus 1, x plus 2, x minus root 7, x plus root 7, okay? Once I know every root corresponds to a factor, okay? So I probably would word it on a quiz like find all the roots, and for each root, you need to correspondingly write a factor, okay? So this one, we typically would not have factored this because this wasn't a perfect square. But if the root is square root of 7, there is a factor x minus square root of 7. If the root is negative square root of 7, there is a factor x plus square root of 7, okay? So I would probably word it to where this is the complete factorization of this, okay? Before we had been doing a real factorization, or rational factorization. Okay, so for every root, there is a factor, okay? So what if the square root of 5 was a root? What would be the factor? X minus square root of 5, okay? So you know that if I give you a root, x minus that is your factor, okay? So I think I took up all the space here. Yeah, I had extra space that I did not take for that. So find all the roots to this next polynomial. So first thing I want to look, are there any shortcuts? What is 1 minus 1? 0. 0 minus 5? Negative 5. Negative 5 plus 7? 2. 2 plus 10? 12. So x equal 1 is not a solution, okay? So I need to figure out what are all the possible roots. So the possible roots are plus or minus what? The factors of 10 divided by the factors of what? Of 1. So this is just plus or minus the factors of 10. 1, 2, 5, and 10. Okay? Now I know that x equal 1 does not work. Okay, so x equal 1 is not possible because my coefficients do not add to 0. Now, if you did not recognize that, it would be no harm to just plug it in and you see that it will not work. So let's try negative 1. So I'm going to start with, let's see, x. If I write my coefficients, that's 1, negative 1, negative 5, 7, 10. And that is my x to the 4th, x cubed, x squared, x, and constant. So let's try this out. If I bring the 1 down, negative 1 times 1 is negative 1. That adds to negative 2. Negative 1 times negative 2 is 2. That adds to negative 3. Negative 1 times negative 3 is 3. That adds to 10. Negative 1 times 10 is negative 10, which is 0. So what does that mean? So x equal negative 1 is a solution. What is the factor? X plus 1. Okay. So I always write that down because I'm going to have to come back to that in a few minutes. Okay. Now what do I do? This is what? This is x to what power? Cube, squared, x, and constant. Okay. So I've got to do it one more time to get it down to a quadratic. So what will I start with? I'm going to try, I'm trying to just march down that list. I know 1 doesn't work, okay? So I'm going to try negative 1 to see if it works again, okay, before I move on. Because if I moved on, what if negative 1 worked again? Then, you know, I would have missed that chance. So let's just rule it out. So let's try negative 1 again. But now I start with these as my coefficients. So I start with 1, negative 2, negative 3, and 10. So if I bring the 1 down, that's negative 1, negative 3. Multiply those, I get 3, and that's 0. Multiply this, I get 0, but that tells me that negative 1 doesn't work. Okay. So now I'm going to move on to what? 2 and negative 2. So let's just try with 2. So 1 times 2 is 2. Add that to get 0. 2 times 0 is 0. Negative 3. Okay, that does not work. Okay, what will I do next? I'm going to try negative 2. If I bring the 1 down, 1 times negative 2 is negative 2. Add to negative 4. Negative 2, negative 4 is 8. Add that to get 5. Negative 2 and 5 is, did I do that right? Negative 10, right? It's what? Where's oh, this is a positive 10. So that still was there, okay. So this gives me a 0. So you can see where, okay, just a minor arithmetic mistake. If you find yourself on a test and you're trying everything and nothing's working, somewhere along the line you made a arithmetic mistake like I just did, okay. So what does this mean? X equal negative 2 is a solution, and the factor is what? X plus 2. So in this case, I've got f of x equal, what are the factors? X plus 1, x plus 2, and what is this right here? That's x squared minus 4x plus 5. Okay. Are there numbers that multiply to positive 5 and add to negative 4? Not a trick question. If it were a negative 5, I could say a negative 1, a negative 5, and a positive 1. Okay. So how do you think I'm going to have to solve that? Quadratic formula. So, yep. So my solutions are going to be x equal negative 1, negative 2, and then I have to solve this guy. X squared minus 4x plus 5 equals 0. This is in the form ax squared plus bx plus c equals 0. Okay. What's b squared minus 4ac? That is going to be what? Negative 4 squared minus 4. All right. So that is what? 16 minus 20, which is negative 4. What kind of roots am I going to have? Not irrational, but complex. Okay. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2 times a. So this is 4 plus or minus. What's the square root of negative 4? 2i over 2. So this is what? 2 plus or minus I. So my roots are negative 1, negative 2, and what? X equal 2 plus I and 2 minus I. 2 plus or minus I, either one. Okay. So these are all the roots of this polynomial. It had 2 real roots and 2 complex roots. Okay. So don't look at it as a failure in life when you get to the quadratic formula. Okay. When you get to the quadratic formula, just know that that's something you learned last semester and you're good with it. Okay. So every one of these quadratics can be solved. Okay. So let's look at the next one. What are all the possible rational roots? So plus or minus the what? Yeah. Plus or minus the factors of 2 divided by the factors of 6. What are the factors of 2? 1 and 2. What are the factors of 6? Yeah, 1, 2, 3, 6. So this is plus or minus 1, 2. Divide every number by 2 and you get what? 1/2 and 2/2. 2/2 is 1. Divide every number by 3 and you get 1/3 and 2/3. Divide every number by 6 and you get 1/6 and 2/6. What is 2/6? 1/3. That's already on my list. Okay. So those are all my possibilities. Now, before I do it, what do I always want to check? Let's check the coefficients. What is 6 plus 11? 17. What's 17 minus 6? 11. What's 11 minus 9? 11 minus 9 is 2. 2 minus 2 is, so what does that mean? I mean, x equal 1 is a root. So when I put a 1 here and I try it, what better happen? It better work. If it doesn't work, who made a mistake? Yeah, you did. Okay. So let's bring this down. 1 times 6 is 6. Add to get 17. 1 times 17. Subtract 6 to get 11. 1 times 11. 11 minus 9 is 2. 1 times 2. Add that to get 0. Okay. Now, here's the question. Should I try 1 again? Why not? Yeah. Naman realizes it's not going to work. Why is it not going to work? Guys, this is what? 6x what? 6x what? Cubed plus 17x squared plus 11x plus 2. Do those coefficients add to 0? No. Right, so I could try 1 again. Not going to hurt anything, but I know what? It's not going to work, okay? When I look at this, if I'm solving this, what are the only kind of roots I should try? Negative roots, okay? So I could try 1, I could try 2, but they're not going to work. From now, my strategy should be to try all negative roots, okay? So I know that x equal 1, that is a root. What's the factor? X minus 1, okay? Now I need to work on this problem, but I'm only going to try negative roots, okay, from here on out. So you see how these two shortcuts, I mean, they don't save you a whole lot of time, but they do save you some needless trial and error, okay? Does everyone see why we only try negative roots now when you have all positive coefficients? So I'm going to try negative 1. So let's try negative 1, 6, 17, 11, and 2. Negative 1 times 6 is negative 6. Add that to get 11. Negative 1 times 11 is negative 11. Add that to get 0. Negative 1 times 0. It looked like that was going to work, but it did not work. Okay, what will I move on to? I'm going to move on to negative 2. Okay, so let's try negative 2. Negative 2 times 6 is negative 12. Add that to get 5. Negative 2 times 5 is negative 10. Add that to get 1. Negative 2 times 1 is negative 2, and there we go. Okay, so I started out with what degree? 4th degree. What does this mean right here? X equal negative 2 is what? That's a solution. What's the factor? X plus 2 is a factor. And what does that mean right there at the bottom? That's 6x squared plus 5x plus 1. So now I know that f of x is, what are all the factors? X plus 2, what? X plus 1, and what? 6x squared plus 5x plus 1. Now, am I done? I need to factor the quadratic or solve a quadratic formula. If this factors, is it problem? Oh, x minus 1, you're right, sorry. Thanks. There are many places mistakes can be made, okay? That's why I always try to write this down, because at the moment I figured it out, we wrote x minus 1 as a factor. When I get to here, I should be able to just copy down what I wrote. So I made a mistake, but that's why I write these intermediate, this is a factor, this is a factor. So that when I get to here, I'm just, okay, that's a factor, and then read what's here, okay? So if this factors, so 6x squared plus 5x plus 1, I would need two numbers that do what? Multiply to 6 and add to 5. Are there numbers that do that? Multiply to 6 and add to 5. 2 and 3, okay? So this is what? 6x squared plus 2x plus 3x plus 1. Our old friend, factor by which method now? Grouping. What do I factor out of the first two terms? 2x, and I get 3x plus 1 plus 3x plus 1. This then factors as what? 2x plus 1 times 3x plus 1. Okay. So the final factorization is x plus 2, x minus 1, 3x plus 1, 2x plus 1. What are all the solutions or the roots? What are they? Negative 2, positive 1, yeah, negative 1/3, and negative 1/2. Are all those on my list of possibilities? 1/3 is 1/3 and 1/2 on the list of possible roots. Yeah, 1/3, 1/2. Okay, so this one had all rational roots, and they were all on the original list. Okay.